All right, and we're live. Okay.
Okay.
Hi everyone, and welcome to our first live code of March 2022. We're so glad to have you here, and we hope you learned something new today. Before we start, I just want to do a quick announcement. Our parent company V45 is hosting three separate training programs at Black Hat USA, attacking the application supply chain, Purple Team AWS, and the DevSecOps Masterclass. There's an early bird discount right now, so check out the Black Hat website and book your seats soon. Anyway, back
Yeah.
to the live code. Today, we'll be joined by Sharath Kumar, one of the instructors at AppSecEngineer. He's an expert on cloud and container security, and he's been handling all our courses on Azure security. So if you like this live code, you can see more of him over there. If you guys have any questions, by the way, please feel free to drop them in the comments, and he'll be sure to answer them. All right, the floor is yours, Sharath.
Thank you. Thank you, Anish. Thanks for the warm introduction. Yeah, let's get started. I'm assuming the screen is visible now. All right. So let's get started with our live course session. So first of all, I would like to welcome you all for this live course session. This live course session is about privilege escalation in Azure. So before we dive into all of this, let me introduce myself. My name is Sharath Kumar. I'm a principal researcher at V45. I head the R&D department at V45, where I focus mostly on research and development. I started my journey in V45 as a developer and then moved into DevOps, DevSecOps, and now I'm into complete training and research. During my development days, I worked on a few products like Orchestron and other things internally. Orchestron is one such product where you can correlate results from multiple tools. Suppose if you have tools like Burp, Zap, Checkmarks, Nessus, or whatever the tools you have, you can correlate all those results in one single platform and see it as one single vulnerability. That is how Orchestron can come in handy. Suppose if you have multiple tools and if you're dealing with some kind of a overwhelming reports. I'm a Python developer by heart, but I also do a lot of AppSec automation using Node.js, Java, and Golang. I'm a trainer and speaker at multiple OWASP and Black Hat events, and I also handle private trainings for a couple of private organizations. And I also deliver talks, webinars, and even trainings for meetups around the globe. I've contributed to a bunch of open source projects like DBFast, Threat Playbook, RoboBug2, and even I've also drafted few templates for Nuclear. So this is my journey. In case if you are interested to know more about me, then you can check out my Twitter and LinkedIn handle. So without further ado, now let's get started with our live code session. So the session will be like this, where we'll be starting with introducing the virtual machine or understanding the virtual machine. Why do we even need virtual machines and what's the point of using virtual machine? And then we'll look at the shared responsibility model. So whenever you're trying to use virtual machines on cloud, there is something called shared responsibility model. Not only virtual machines, in generally, whatever the services you use on cloud, whether it could be AWS or Azure or G-Cloud, it has something called shared responsibility model, where you divide the responsibility between the cloud provider and yourself. So that is what a shared responsibility model will be. So we'll discuss about this in a greater depth when we get to it. So after we discuss the shared responsibility model, we'll talk about the MITRE attack framework. Whenever you're trying to test your application in terms of an attacker perspective, then you can follow this MITRE attack framework. In this framework, you have multiple matrices where you can check out the attack metrics for containers, for Kubernetes, virtual machines, and there are a bunch of other compute services, whatever you can look for. All of them have a matrix where you can follow that matrix and test out the application and see whether they are vulnerable and also understand the threat actors and adversary in terms of understanding the vulnerability. And then we'll start attacking the virtual machine where we'll perform an attack, compromise the virtual machine, and then we'll try and privilege escalate to other services. This is how this session will be laid out. So now let's get started by understanding what Azure is. Azure is nothing but a cloud computing services from Microsoft. So just like you have AWS or GCP, Azure is one such cloud service provider. Using Azure, you can have various services like infrastructure, platform, software, and even serverless. All of these services is provided for you so that you can pay for that particular usage and then have it for depending upon your workload. And there are services like compute, databases, functions, Active Directory, user management. There are so many services like that you can look after in Azure. And most of the user management within the Azure happens using Azure Active Directory. Usually in the enterprise environment, there is something called Windows Active Directory where most of the user management happens on Windows Active Directory. But in Azure Cloud, the whole user management or the identity or the access management completely happens on Azure Active Directory. So they have a separate variant of a cloud, which is technically an Azure Active Directory. And Azure is mostly excels a kind of a does a better job in terms of handling the hybrid cloud. Suppose if you have some private infrastructure which you don't want to take it to the cloud, then Azure helps you connect to that as well. And you can also have public cloud. So if you have a mix and match of both private and public cloud infrastructure, then Azure is something you should be looking for. So one of such services from Azure is Azure Virtual Machine. So this is an high availability computing resource. So there are other resources like container or serverless, which are very ephemeral in nature, where they run for few seconds or few minutes, and they're gone. Suppose if you want to run a workload 24 by 7, in that case, you should be looking for Azure Virtual Machine. And they also have another other service called Virtual Machine Scale Set. Suppose if you want to load balance multiple virtual machines, then you can look at them. This virtual machine comes with two operating system flavors. One is Windows, other one is Linux. So depending upon your workload, you can choose the operating system. And it also has a bunch of hardware characteristics like CPU, memory, hard drive, and network interface card. As I said, depending upon your workload, you can increase the CPU limit, decrease the memory limit. It completely depends on your workload. And the pricing is based on a pay per minute subscription. Suppose, even though if you're not using the virtual machine, if the virtual machine is still running, you're still paying for it. So it completely depends on pay per minute schedule on Azure. And again, this pricing completely depends on type of hardware you choose. Suppose if you choose a 4-core server, there is one set of pricing. Suppose if you choose a 16-core server, there is another set of pricing. So the pricing depends on the service at the same time on the time of you use for that particular virtual machine over there. And the networking completely happens on virtual network. In Azure, there's something called Azure Virtual Network, where you have components like subnet, network interface cards, and even network security group. So you can specify an IP address, expose a port internally or externally. You can do that. And you can also control the network access using something called network security group. The complete networking piece is handled using Azure Virtual Network for your Azure Virtual Machine. And using to use your virtual machine or to use your virtual machine, what you can do is you can host your databases, you can host your applications, and you can also host your machine learning or artificial intelligence workload. These are all the workloads which usually run 24 by 7 so that users whoever need access for any point in time, they can host this, but they can access this virtual machine where it is hosted as a 24 by service over there. But there is one thing you should keep in mind whenever you're using the virtual machine, that is a shared responsibility model. As I said, shared responsibility model is a responsibility division between a customer and a cloud provider. In this case, the cloud provider is the Microsoft. And whatever you see in the blue, in the dark blue section, that is your responsibility. And this responsibility depends on type of service you use. Suppose if you're using a software as a service, there are separate set of responsibility. For a platform as a service, again, separate set of responsibility. And even for infrastructure as a service, there are separate set of responsibilities. Since virtual machines falls under infrastructure as a service, let's look at what is that we should be taking care of in terms of responsibility division with it, in terms of our virtual machine. So if you look at here, there are a bunch of responsibility on the customer side. On the cloud side, there are other set of responsibility, like whatever comes out under a physical security, like if there is any natural calamity or a fire accident or any of the physical theft kind of things, that is something an Azure will take care. You should not worry about that. But if you are hosting an application, or if you are trying to install an operating system, or if you're trying to expose the service to the outside world, all of that falls under a customer responsibility. And what device you try to connect, what user you try to give access to, and what data you store on that particular virtual machine. All of this are completely a customer responsibility. Suppose if a customer fails a responsibility, then there are few attacks like SSH and RDP brute force, where somebody can look at the SSH port like port 22 or RDP port like 3389 and try and brute force the credentials and get access to virtual machine. In that case, if a virtual machine is compromised, then cloud provider will not take any responsibility, because if you look at the responsibility here, it says that the network controls is completely your responsibility. So in that case, you should keep in mind that an SSH or an RDP brute force kind of an attack is completely my responsibility if I'm using virtual machine. And similarly, whatever the application I host on virtual machine, if that application is vulnerable to some kind of an remote code injection or any shell access kind of an attack, in that case, even the attack or whatever the breach that happens, that is completely a customer responsibility. And
Just
there
to
are even, yeah,
sorry,
sorry.
just to interject here, there's a comment with a question here.
Uh-huh.
Can I just put it up here?
Give me a second. Yeah. How we use MITRE Att&ck framework. Vipul, that's a great question. I'll talk about that in the next slide. Just hold on for a few seconds. I have that in the next slide. Yeah, all right. So here, apart from SSH and RDP brute force and apart from application compromise, there is something called ransomware attack as well. Suppose if an attacker gets access to virtual machine and if they are able to successfully inject the malware, then they will be able to take a complete control of your virtual machine and encrypt all of the files within virtual machine, and they start demanding a ransom for decrypting those files. Such attack also happens, and all of this comes under customer responsibility if you don't take good care of a virtual machine. So how do we know whether this particular attack is possible? Whether an application can be compromised, whether an SSH can be brute force, whether a malware can be injected? How do we know that? How do we test it? So if you have such questions, there is definitely something you should be looking for, which is a MITRE attack framework. MITRE attack framework, MITRE attack framework is a framework where you talk about, where you see about a lot of tactics and techniques in terms of testing your application. This, whatever the attack you see here, is an abbreviation for adversarial tactics, techniques, and common knowledge. It was developed by a non-profit organization called MITRE, where it discusses a lot of tactics and techniques and also few information about a threat actors. And it creates some kind of a knowledge base for you to understand how a particular component can be compromised, how a virtual machine can be compromised, how a Kubernetes can be compromised. It gives a complete list of tactics and techniques what the attackers will try and do. Similarly, you can use the same technique to test it in terms of a white hat hacker kind of a thing, and then test it out as a blue teamer and see whether your application or infrastructure can be compromised. That is something you can look at this particular framework. Here, the matrix, in the matrix, whatever the matrix you see there, it has something called a column header and a column value. The column header stands for tactics and the column values are techniques. For every tactic, there are more than one technique. For example, if there is a tactic called initial access, there can be multiple techniques like discovering an application exposed to the outside world, or finding out the credentials, or anything like that. Those are all the techniques for one single tactic called initial access. And it is not necessary that you should be testing out everything or you should be looking for all the techniques. Suppose if your objective is to find out whether an RCA can happen, in that case, you need not have to try out all the techniques, but you can do a mix and match and test out those techniques and see whether an application can be compromised or an infrastructure can be compromised. This matrix is mostly used both by red teamers and blue teamers, and mostly by red teamers, I can say, but blue teamers use it as a reference model to secure their infrastructure. And the tactics, there are about 12 different tactics. There is something called initial access, execution, persistent, privilege escalation. So let's look at this as a matrix in their own website. So here, there is a matrix, which is for, let's look at a Linux attack matrix. So in a Linux attack matrix, there is something called initial access, which is a tactic. For that tactic, there are a bunch of techniques. Whatever you see in the column values, these are all the techniques. If you want to know more about this, then you can just click on this and see what is that the tactic, what is that technique actually means. It says that adversary may gain access to a system through a user visiting a website. Something like this, you can know more about this in terms of technique, and all of these techniques falls under one single tactic here. You can use this as a reference model to test out your application or infrastructure, whatever you're trying to test out. So for our virtual machine, we have crafted a particular set of tactics and techniques. So this is how the matrix we follow. There are a bunch of tactics we follow. One, we'll start by reconnaissance, and then we'll look at initial access, execution, persistent, and then finally we end up creating an impact. So if you look at the reconnaissance stage for a virtual machine, we look at to discover any public facing app. Suppose if there is any application running on that particular virtual machine, then we'll try and compromise that application. Are there any exposed ports, whether there is any port 22 being open or port 443 being open or port 80 being open? All of this we test out using tools, and then we find out whether there are any exposed port. Similarly, we also look for exposed dashboard. There are scenarios where people host a particular application and expose the dashboard without any credentials, kind of a thing. For example, even Microsoft made that mistake where they've exposed an Elasticsearch cluster on a virtual machine to the outside world without any username, password, kind of an authentication. So such things happen. So all such things can be tested out using a reconnaissance base. At the moment we find out such exposed dashboard or an exposed app, we'll try and look for whether we can get any credentials. And these credentials can be found out through methodologies like brute force or some kind of random guess. We'll find out, we'll run some tool and find out SSH and RDP credentials. Sometimes we also compromise the application by credential stuffing. We'll do some kind of a social engineering and then find out and see whether an application can be compromised using some kind of a guess the username and password. And after we get access to an application, we'll perform an application exploit to see whether we can get an RCE on that particular application box or whatever the virtual machine they're trying to run behind the scene. We'll try and get the RCE, and then we'll maintain the persistence through some kind of a shell access. And once we have a shell access,
Sorry,
yeah,
we have one more question here. Can I just put that up?
sure.
Yeah.
Is this framework for VM is available on MITRE website, or how is it created? That's a good question again, Vipul. So here, this framework, whatever we are trying to put up for a virtual machine here, this is created by our team. Similarly, there are multiple matrices. So maybe I can share this link. We can just go for attack.mitre.org. So here there are a bunch of matrices. For Linux, there is a matrix. For containers, there's a matrix. Similarly, there is something for Kubernetes as well. Kubernetes attack matrix, which is developed by Microsoft itself. So if you look at a matrix for Kubernetes, it is something like this, which is developed by some organizations develop it and give it out for people's usage. And whatever you see in the slide, this is created by V45T. This is something we use it. And this is not a complete matrix, by the way. So whatever we put it here, these are all we are trying to fit in few things within this particular slide. So this is not a complete matrix. There is much more to it. Just to fit into this particular slide, I have picked and choose a set of tactics and techniques. So you can talk to a pen tester or a threat model kind of people, and then they will try and create a matrix for you. So based on that, you can test out your virtual machine or any other component you're trying to test for. Hope I have answered your question before. All right. So now using this matrix, we'll try and maintain a persistent through shell access. And sometimes we also install a backdoor and see whether we can keep that session alive so that we can fetch out information whenever we have time later. And in terms of not alerting alert management system, we disable firewall. Sometimes even we uninstall the agents. If there is any logging and monitoring agent, we try and uninstall it so that an alert is not triggered. And sometimes we disable the firewalls to get more access to internal infrastructure. And we also try and access the metadata endpoint. In cloud resources, there is something called metadata endpoint, which is an IP address called 169.254.169.254. We'll try and access that metadata endpoint to see whether we can get some kind of a IAM credentials or a JWT token so that we can escalate privileges and access other resources within that particular network. That is something we look at in terms of discovery. And we also do network mapping to see whether what is there in that particular subnet. Suppose if you have database and virtual machine, both of them in the subnet, we'll run some kind of a network mapping tools, which will map out all the IP addresses and give us saying that, hey, in this particular IP address, this particular service is running. So that is something we look at in terms of network mapping. And we also look for a few credentials within the system. That is, we look for HCD passwords if there are any hard-coded files like .env or secrets.json or anything like that which is put as a file in terms of credentials in that particular virtual machine. That is also something we will look for in terms of credential access. If we get credentials, then we'll obviously try and privilege escalate to other services. Sometimes we'll try and read the mount volume. Sometimes we will access the storage. Sometimes we also access services like Key Vault or any other secret store which is mounted to that particular virtual machine. So we'll privilege escalate to other services and we'll compromise the other services as well. It's not only the virtual machine which is compromised, we are also compromising other services which are connected to that particular virtual machine over there. And we'll also try and create an impact where we'll try and delete some sensitive files. Sometimes we also bring down the whole resources using DDoS attack or a DOS attack. And sometimes we take down the whole resource by performing a resource hijacking using by running some kind of a crypto miner or something like that. And then we try and bring down the resource. This is how we test a virtual machine and find out how we can compromise virtual machine before it goes to production. So this all happens at a staging level or a testing level or a QA level. Once everything is tested out and everything is fixed out, only then we take this to a production environment. So for today's attack, we'll be performing a bunch of attacks, tactics and techniques. So here we'll try and discover a publicly exposed port on a publicly exposed IP address. So a virtual machine is running on a particular IP address. We'll try and expose that particular IP address to the outside world, and we'll try and find out what ports are exposed on that particular IP address. Once we get the IP address, we'll try and run a brute force tool to find whether we can find an SSH credential. If we are successful in finding an SSH credential, then we will get those credentials and we'll get a shell access, and then we'll try and read the credentials within the virtual machine, and then we will escalate the privileges to a storage. This is what we are trying to do in our attack. So let's get started with our reconnaissance phase.
Before you do that, Sharath, one more question.
Okay.
Yeah.
Is it necessary to consider all tactics and techniques while creating metrics, or like how we decide, shall we use what is provision from MITRE, or we can customize it, how customization happens? So here, MITRE attack framework gives you a bunch of tactics. So that is, as I said, there are about 12 different tactics. That is initial access, persistence, or whatever is that. So you can use them as a reference, but you need not have to limit to that. You can use your own thought process to find out, hey, maybe this is something which is missing. So you can add your own tactics and techniques and try and compromise or try and test the particular application or infrastructure. That is something you can do. As I said, the customization happens at your end. So if you look at the matrix here, you can add another column and then start adding the tactics and techniques. That is something you can do. So you can create an attack matrix and give it to whoever is trying to test that particular application or infrastructure. And they will use this as a reference model to perform the testing, whatever they're trying to make that. All right, so let's look at the attack now. So here I have a virtual machine running on port 13.86, sorry, on an IP address called 13.86.95.118. So I have a tool called Nmap where I'll be using it for finding the exposed ports on that particular IP address. So I'll just ping that IP address and see whether I can ping that. And quickly, I'll also perform a quick scan to see whether I can find out any exposed ports on this particular IP address. So it will take a while. It will perform the scan and come back with a result saying that, hey, this particular IP address is open to the outside world. So in this case, it clearly says that there is a port 22 being open. So as you all know, port 22 is used for SSH. Suppose if one has to make a deployment to a virtual machine, they'll have something called SSH, where they will access the virtual machine using SSH. So SSH can be accessed through multiple authentication modes. One can be with username and password, and one can be with username and private key. So if your password is given, then brute force is possible. So if it is a private key or a public key kind of a thing, then you should have a key. So let's see whether we can brute force this with some kind of a password and see whether we can compromise this particular application or this particular virtual machine here. So I have a command here. Give me a second, which is again done by again using an nmap. So let me export this particular IP as an environment variable so that I need not have to keep typing it again and again. So here's my IP address. I'll just set it as an environment variable. So now I will use the nmap tool to brute force the SSH credentials and see whether I can compromise this particular virtual machine using a brute force technique. So it will try and perform the brute force, and the brute force is usually like this. It sends a random username and password pair to find out whether a particular credentials is valid, so that it can get some access onto this particular machine. So it keeps on going. So if there's any alerting system in the place, then it should throw an error by now, because usually by 10 or 20 at the wrong password right, they should try and alert saying that, hey, somebody is trying to brute force an SSL. In this case, clearly there is no alert mechanism. So it is trying and sending a lot of username and password pairs here. So let's stop this and see whether we can increase this particular attack using a different tool. So here we have another tool called Hydra. So we'll use this Hydra tool, and we'll also perform the same SSH brute force attack using a password name, using a username and password pair. So it has something called top 20 common SSH password, which is written in a TXT file. We'll use those passwords and see whether it can brute force with that particular credentials and come back with whether that is successful in terms of attack. So it clearly says that there is a username called admin user and a password called password. Actually, this password is not a strong password. For some reason, Azure has allowed to create this as a strong password. So because it follows all the whatever the password characteristics they say. So it has got an uppercase, it has got a special character, and it is at least 8 character length. So it satisfies the user whatever the password they are trying to create in terms of a password policy. It satisfies. So using this password, let's see whether we can access this virtual machine and privilege escalate to other services. So it clearly says that the username is admin user. Let's SSH using admin user. And I've already mentioned my IP address as an environment variable. So let me SSH into this box. So it is asking for a password, luckily. So I already have a password. So I'll just use this password. Now I'm successful in terms of compromising a virtual machine. An SSH brute force attack is successful, and now I have a complete access to my virtual machine here. So let's see what I can do with this particular virtual machine over here. So usually we look at a few sensitive files like etc password. So if you look at etc password, there are a bunch of username password. So I can also combine the etc shadow. I think that's a she shadow. Yeah. So there are a bunch of username password. Now I can try and combine them. So we don't stop the attack here. The objective is to privilege escalate to other services. As I said, there are a lot of services which are connected to this particular virtual machine. So while pen testing this kind of an environment, we also look for a few sensitive files or a sensitive folder. So we try to look at a sensitive folder called etc. As I said, etc is always a sensitive folder where you have a username, password, or shadow file, whatever is there. So we tried to list out this particular directory here, and then we started looking at each and every directory and each and every file. So we started looking at each and every file, and then we accidentally discovered something called this particular file, which actually says that it is SMB credential. We didn't know what this was initially, so we started looking at Let's see what this particular file is. And then we went and tried to list out and see whether what's in this particular directory over there. It has something called cred. Again, it says that there is some credentials in this particular directory here. So we tried to list out this particular credentials again. We tried to read this credential. So it says it has got something called a username and password, and that is completely in plain text. So if we're curious to know what is this username and password and what is this SMB credential, it says SMB. Looks like there is some mount volume or some kind of an SMB volume being mounted onto this particular system. So we are not sure, but we got the username and password. And again, we are not sure what is this username and password. And we started digging a lot to find out what is this username password about. So we tried to start Googling about this particular folder. Okay, sorry about that. Okay, looks like it's not allowing. So we started Googling this. So we went to Google and started looking for Att credential. It clearly said that mount SMB Azure file share on Linux. We started going through the documentation to see whether what is this credential all about. And then we realized that this credential is a storage account credential. Azure has something called storage account. Azure storage account has a multiple set of services like it where you can store block files, you can mount a volume, you can also use it for table storage, and you can also set some kind of a queue messages as well. To access all of these services, Azure Storage has multiple access control methods. One is called a share key authorization, another one is called as a SaaS token authentication, and there's another thing called Azure AD credential. So when after doing some research, we realized that whatever the credential we try to see here is a shared key credential. Our storage account shared key credentials are usually like a master key for a complete storage account. So whoever gets this particular username and password or this particular key over there, they'll be able to compromise a complete storage account where they can create a rogue block file, or if there is any log file, they can delete it, or they can do anything that is possible, anything they can do on the particular storage account. So we looked at this credential and we started crafting out our own payload or our own script to find out whether this credential is valid. So we crafted a simple file. Let me share the file here. So here we crafted a simple file. This file is about, it's looking for a particular account name, which is actually a storage account name, and it is also looking for credential. So whatever we see here, username, that is the storage account name, and whatever we see as a password, that is the storage account share key. So we took both of this key and then we used a Python SDK for a blob service. And then we created a rogue blob by the name testing followed by some random name. And then we also created a random file to see whether we can upload it. And luckily we were successful. We didn't know that whether this works, but we tried this attack and then we realized that, hey, this attack is possible. So that is something we can look after in terms of compromising the storage account. So here, let's attack this. Let's set this credentials as an environment variable. So here I have my account name to be set. So I'll just go to this folder or this particular terminal here, and then access this username and set it as an environment variable for my attack file to run. And I have my credentials also to be set as an environment variable. So whatever I see as a password is the credential for my storage account. So now it's time for me to test out my theory. So let's run this Python file. So the moment I run this file, it says that it is able to create a storage block and also also upload a particular rogue file to that particular storage account over there. So I not only compromised the virtual machine, but I've also compromised the storage account because there were some credentials in plain text within the virtual machine. So which I was able to find it out because it was in the sensitive directory called etc, and I was able to easily get it. And then I'm trying to compromise a virtual machine over there. So this is how a privilege escalation would usually happen. So not only this, it's not only the storage account which you can compromise. There are also other things you can compromise. So it looks like my SSH this thing is gone. So okay, let me SSH into my box again. So what was the password I had? I think it is password. Let me try that. Okay, I forgot the password. Let me try it again. Give me a second. Uh-huh. Or let's run Hydra again. Better it is so that it is faster to find out. So Hydra will again run, and again it will find out the password. Yeah, clearly I forgotten the password. Yeah. So now I'll use this SSH credential. And not only I can compromise this, but as I said, there is something called metadata endpoint as well. So if you look at this particular URL, which is 169.254.169.254, and then using this metadata endpoint, I'll try and get a token for my Azure vault or a key vault. So if I just send this curl request, I'll be able to get a JWT token, which has permission to access my key vault. Usually in key vault, people store their secrets and keys and other sensitive information. So using this token, you can privilege escalate to key vault as well. This is how a privilege escalation would usually happen on virtual machine. And in terms of whenever you're trying to consider using a virtual machine, try and look for SSH credentials truthful and also the application. Though if somebody gets access to a virtual machine, then they'll be able to privilege escalate other services like storage or any other services which are connected to that particular virtual machine over there. So I am done with my talk. If there is anything in terms of question, I'm happy to take them. Any questions?
I think they can post the questions on the in the comments at any point, so we can reply to them later on as well. So that's not a
Sure,
problem.
sure.
Anyway, thanks so much for that, Sharath, and thank you to all our viewers for joining us. We'll be posting a link to our Discord server, an invite link to our Discord server. All of you can join. Please feel free to join our Discord server, and we can keep this conversation going over there. And
Yeah,
this, as to my understanding, this demonstration you showed today is part of our courses on AppSecEngineer, right?
yes, yes.
So
We
you
have
can
a
ask.
course dedicated. We have a course dedicated to privilege escalating to Azure services.
Great. Yeah. So if you guys are interested in taking this to the next level, you can also check out our courses on Azure security and other cloud security specialities as well. So thank you guys for joining us and have a good night. Yeah.
Yeah.
Bye.
Thanks for your time. We'll see you in some other live code session.
Yeah.
Bye bye.
See you next month. Bye. See you, Sharath.
Bye bye.